Let's continue with this example. This says the Maclaurin series for the natural log of the quantity 1 over 1 minus x is given as x to the n over n, with the interval of convergence from -1 to 1, including the left endpoint but not including the right endpoint. Find the Maclaurin series for the natural log of the quantity 1 over 1 plus 3x and determine the interval of convergence. Well, we're supposed to know the series expansion for this as well. So we know that the natural log of 1 over 1 minus x is going to equal here, starting at n equal 1. So it's x plus, at n equal 2, x squared over 2, and so forth. No factorials. There we go. And so we're going to take what we know about this function and its corresponding series, and everywhere there's an x, we're going to make a change. How do I get from minus x to plus 3x? Well, that's substitute in a negative 3x. So if that's all I have to do to the function, what I do to the function, I'm going to do to the series as well. Everywhere that the original series had an x, I'm going to put in a negative 3x. So there's the Maclaurin series, and I could clean it up. Negative 3x plus 9x squared over 2 plus, actually that will be a minus 27x cubed over 3 plus 81x to the 4th over 4 plus ... So there we are. There is our Maclaurin series for that new function. Now we want to know the interval of convergence. Well, instead of going to the nth term and saying that our series looks like this, we can take a shortcut, because we know that the interval of convergence for this series is -1 less than or equal to x less than 1. I'm getting that right from the information that they gave us. So the manipulation that I made on this series says everywhere that there was originally an x, and there it is right there, I'm now going to write a negative 3x. So now I have, if I divide each term by -3, this might be a little tricky, but if you'll stay with me, I think you'll be okay. When we divide by or multiply by a negative value, it reverses those signs, right? So now I have a positive 1/3 is greater than or equal to x, which is greater than a negative 1/3. Now be careful, because we don't normally write our inequalities that way. We normally go from negative to positive along the real number line. What I have written here is equivalent to what's written right above it. I just went from negative to positive, so I flipped those signs back around. That's just fundamental algebra 2. Nothing fancy there, but you've just got to think about those inequality signs. So the interval of convergence for this series, we didn't even have to run the absolute ratio test on the general term. I want to be clear, if we had, then we would have gotten the same result. But we did it in a lot less time. And this is where those operations on power series, especially operations on known power series is such a time saver. So I want you to remember that. That's one of the main reasons we're doing this example. I want you to remember that when you're doing your series free response questions, if you can do anything that is saving time, you need to do that. This is a timed test. So same series expansion, and it says find the value of -1 to the n over n. Well, notice what that is doing. Basically, it's saying x equals -1. So if x equals -1, remember the sum of any series is the function that goes along with it. Again, another time saver. I don't have to expand it and put values in and all that kind of stuff and see what's going on. Here, x is -1. So the sum of this series has to be the natural log of 1/2. And that was quite quick. But I recognize that there is a relationship between my general term and that term. And the relationship is where the general term has x, the new series has -1. So that's all that was done there. All right? So let's look at the next part. Same series. Give a value of p such that this alternating series, -1 to the n over n to the p, converges, but this second positive series diverges. Give reasons why your value of p is correct. Let's go back and let's just, in general, talk about p series. We know that for any value less than or equal to 1, this p series diverges. We also know that for any value of p greater than 1, our p series converges. So what we're going to do is I'm going to start with the positive one because that's the most obvious one. We're going to do a manipulation on that. If that's true and we want to know where it diverges, we're going to pick up this information and we're going to say it must be true that this series, 1 over n to the 2p, diverges when not p, but when 2p is less than or equal to 1. So specifically, the p-value would be when p was less than or equal to 1/2. So here's what we want to do. We want to see when p is less than or equal to 1/2, because it says find a value of p. Well, I have found a value of p that makes this a true statement. So now all I'm going to do is go back to my alternating series and plug that value in for p. Is it true that that converges? Well, if this was a positive series, it would diverge. But it's an alternating series, so let's run the alternating series test. Take the positive counterpart. If we get 0, that converges by the alternating series test. So the value of p must be positive 1/2. As simple as that. When it comes to your series work, you are going to have to critically think and problem solve. You are going to have to find different ways to answer these questions as straightforwardly as you can without wasting a whole lot of time. And when it brings things like p into it, especially 1 over n to the p, and starts talking about converging and diverging, it's pointing you to p series. So come outside of that and just remind yourself, okay, what do I need for p series to converge and or diverge? And then work from that and see if you can problem solve your way through it. So here's the last one. D says give a value of P such that this positive series diverges, but this positive series converges. Now, remember, and the first one they gave us is just a true generic positive P series. This one is going to diverge when P is less than or equal to 1. So what would that do here on the other one if we plugged in 1 over n to the 2p? Would it be true, let's just see, we're just problem solving, that this would diverge in the case that p was less than or equal to 1/2? Well, let's try it. All I did was take this, and where it has a p, I put a 2p, and then I solve that for p. So let's say I plug that, because we want this one to converge. We've already proven the first one diverges. It's the generic 4p series. So let's rewrite this one, substituting in 1/2 for p. And let's see if we can prove to the AP reader that we know that it converges. All right? Well, it doesn't. That's the harmonic. The harmonic series diverges. So we know for certain that of the values that we can use, which are those values, because they have to be values here, inside that interval, that we know that we can't use 1/2. So let's explore some more. So should we explore to the left of 1/2 or to the right of 1/2? Should we explore values smaller than 1/2 or values bigger than 1/2? Well, it seems like to me that the difference between diverges here and diverges here is going to be on, sorry, that should be P, is going to be on that interval. All right, so let's try something between 1/2 and 1. We know that one diverges. So to make our work easy, let's try that one. Let's try P equal 1. So we're going to come back in here. We have to show the AP reader what we're doing. 1 over n to the 2 times 1. And so that gives us 1 over n squared. That is a P series where P is greater than 1. This one converges. And as luck would have it, we have found the value of P that is going to make this one diverge and this one converge. So let's tell the AP reader that. When P equals 1, the first series that we had, 1 over n to the P, diverges, but 1 over n to the 2p converges. And we don't have to show them again that we know that's true. We've already shown all that work up there. So there we are. There's our second and final example on this set of videos. And so you get the idea that you're going to have a really good handle on those convergence and divergence tests. They're going to ask you, these last part C and part D on this AP question were theoretical questions, most definitely. And so you had to show that you understood P series pretty completely in order to be able to do these problems. So that's it. There's your last video for information concerning calculus. And come to class next time and we'll work some AP practice problems.